Oh, what's up, everybody? Welcome back. Today we are working on implementing OpenGL for our virtualized graphics card. And today we are continuing on with Mesa integration. So for context, we have been working on this idea of making our own graphics card. But the major problem here is that I don't really know what a graphics card does, right? I have like some idea in my head that we could like make something on an FPGA that does a lot of parallel floating point compute, but like what actually does the GPU need to do, and what is like something that's like covered by software, right? Like here we have like the world's simplest OpenGL program that we've been using an example, right? He sets up like an OpenGL context. This is kind of like boring, but then he goes in here and he says like, I want to set the viewport to like this size. I want to call glClear color, and I want to call glClear. This is like just like make the screen a certain color. And what I don't understand at this point in time is like, does this turn into a command that goes to the GPU that says set the clear color to red, then clear? Is that what happens? Probably not. Does he say clear this rectangle of 1024 by 768 with this color? Maybe. And then what happens if I say like, hey, I want to write a shader program to like move vertices around with this transform? Like, does that get compiled into some sort of like shader bytecode that like is uploaded to the GPU in some way, and the GPU has to like run some instruction processor and run that thing? I don't know. And so the goal here is that by implementing the full software stack, top to bottom, then we should get some sort of idea about what a GPU is supposed to do so that in the future we can make one do those things, right? That's kind of the idea. So the current state is that we have like this virtual machine that we're integrating with called QEMU. This is like an open source virtual machine. And what we've done is we've like embedded our own little PCI device in here. So we've like extended QEMU with our own PCI device, which like acts like when you put the system sees this as like a normal PCI device. What we've done is we've hooked this thing up to like the display of QEMU, and we can like draw stuff in here by just like writing pixels on the screen or by calling OpenGL calls from within our driver. Either of those mechanisms work. We've then written like a kernel driver, and he has this like GPU driver that instantiates himself, driver we'll call it, as like a PCI device driver for this guy. So like the Linux kernel, when he boots, he'll walk all PCI devices and he'll say, oh, there's a PCI device with ID AAAA, because that's obviously the one we picked, right? And our driver will then get like instantiated when it finds that, because he says, hey, Linux kernel, if you see a device with that ID, call me please, I want to check that guy out. He like sets up some like shared memory regions essentially with the PCI device. So he creates like in like system memory, a like chunk of RAM, as well as in like PCI memory, kind of like a chunk of RAM. And he can like write to this thing to say like, hey, here's like some action I'd like to perform. And he can put data in here and like feed that to the PCI device, and the PCI device can look at it and be like, oh, okay, so here's like a vertex buffer or something like that. We've experimented with like writing a little application in user space, app. And he basically like connects to this driver through this API called DRM, Direct Rendering Manager. And this provides some like facilities for like drawing to a pixel buffer on the screen. So just like kind of like put like say like at array 700 500 put a black dot. That will do what we want to do. And we've also experimented with like extending the DRM interface with like ways for us to upload 3D objects. Right? We've given it a vertex buffer and a texture, and we've like colored that text. We've like rendered that thing. We've rendered like our little spinny monkey demo or whatever. And now we are trying to get that was all using like low level DRM calls, basically like specific calls for our graphics card that we implemented. We now want to kind of go one layer down and implement like a Mesa backend for OpenGL that then will do this talking to this DRM handle, and we'll talk to this. And once we have this working, then like hopefully we understand what needs to be done for like a user space program to make a 3D application, right? We will understand what APIs we need to expose here for this to work. So that's the plan. We've been working with a little test app here. So we just set up like a little EGL rendering context and then try to do like a clear of the screen. Eventually we'll hook this up to do like 3D rendering and stuff, but for now we just want to see anything. And basically what we've been doing is we've just been walking through this example, watching it crash and see what happens. So we implemented like a very initial, let's see if we look at like this. This will show us kind of like how we hooked up an entry point for our driver. So basically like all we had to do was create this like DRM entry point, DRM driver descriptor, and set up our driver descriptor with this call. What'll happen is Mesa, when we call like EGL initialize or whatever, he'll like open the GPU that we point to, right? We run this by saying like how do we spell this? Test app dev DRI card 0. This is for like an existing graphics card. So you see he says like, oh, there's a kernel driver, vert IO GPU. Mesa like looks at this string that he gets out of the handle, and he uses that to load a GPU driver. So if we look at card 1, we see a bunch of logs that we've injected, and then a crash because he loaded our graphics driver. Our implementation is quite straightforward right now. We've essentially have this like one function that we have to implement, create screen, right? And this returns some structure that has like a million APIs on it. And all we've been doing is just like slowly moving ourselves forward and seeing like what's the next crash, what's the next crash, what's the next crash, and then doing like the stupidest thing we can think of to support it. We kind of figure eventually we'll get to the point where we'll be able to draw stuff, and then we'll probably see some like actual interesting things by going through that. So that's the plan for today, is just keep going along, trying to figure out where the crashes are, fix the new issues. And yeah, so right now we are kind of at the point where if we return true back here before we try to create a context, I believe we successfully like get out of our application. So let's actually like test that really quick. Let's set up our networking in the virtual machine so that we can run zig build and SSH copy that our application over. Yeah, so this does no crash. As soon as we move this down to an eglCreateContext, we run this again. Crashy, right? So the next steps are just to try to make this function pass, then this function pass, and then these functions pass. Wow. I don't really know how long this is going to take or how hard it is, because we're kind of just like running in blind. We tried looking at the source code for Mesa a little bit and tried like inspecting it with our eyeballs, but I found that I was really struggling to figure out how everything hooked up together that way, and so this seems like a way easier way of probing that problem, right? Just follow the crashes, eventually we'll get something. Yeah, so that's the plan. That's the plan. And let's just fucking get into it. So if we run our thing under GDB, I think we run GDB args test app with dev DRI card 1. He should tell us exactly where he's crashing, which is super cool for us. Super cool for us. And in fact, he does. We get a little backtrace, and it looks like he's in some sort of context creation function, which makes sense. And we can kind of just start looking at stmanager 686. stmanager 686. And this, whoa, 686. This doesn't look like the right spot. stmanager.c state tracker. Oh, 986. I can't read. The 9 flipped upside down. Okay, context create. That makes sense. So there, on our screen API that we were implementing, there's a function called context create, and we just haven't done that yet, right? So if we like look for references here, we can maybe see like what do other people do here? This like no-op one is probably a good clue. Maybe. So they create a context object, and that context object is going to have all the same problems that we have right now, where we have to assign a bunch of functions to that thing. Which makes sense. What does like somebody like vergl do? So they go into a sub implementation in a vergl screen, it looks like, and probably that thing is going to be the interesting piece here. Oh wait, what the fuck? Sorry, I'm a little lost. Here, vergl context create. Here we go. This is what I'm looking for. Yeah, so a lot of these. This looks like probably where a lot of the interesting implementations are, right? We see stuff in here like set vertex buffers, you know, create state of some form, like clear texture, draw vertex buffer object. Okay, so this is where like a lot of the interesting stuff is going. So for now, I think we will kind of follow our existing pattern, where we basically say we will do the stupidest thing we can, which is return something that does nothing. And then all of those things that it tries to use it for will crash, and then we can tackle those one by one as well. So what was it? Screen context create. We will have to implement this. Okay, and we'll take this API and we'll just kind of slap it here. We'll shove a little bit of a Sphero in front of this thing. And I guess we will return null for now. We'll kind of see how that works. Presumably null will not be sufficient. Presumably we're going to have to return something else because with function pointers assigned, but let's start here and just see what happens. So we build this thing with this like mega command line, and then we copy paste a bunch of drivers over to our virtual machine and run it again. It actually looks like it doesn't crash anymore, which is kind of cool. So this creates the context. Oh no, he says error create context. Okay. So where does that come from? We get EGL no context in return. So presumably that means that this guy needs to actually return something of value. So can we do something like this? Pipe context. CTX is allocate the size of a pipe context. And then we just return this for now. This thing needs to be included probably, so we need to include pipe p context. Cool. Yeah, let's run it. I also wanted to remove the verbose build argument from our Ninja command line, so we'll just do that. Okay, there we go. So now we're seg faulting again. That makes sense. And so can we GDB again? And then run. Yo. What's up, guys? And we will just look. It's at stdraw.c. Line number 319. Right. So this makes a lot of sense. This is back on screen. Get param. I thought we implemented this, to be honest. Yeah, I see this. So maybe the context needs to attach a screen to it. He does. Okay, so that's step one. Step one. So struct pipe context star CTX equal this. CTX screen is equal screen. And it looks like, well, I don't really know what this priv thing is yet, but let's assume, you know, we'll tackle it as it comes. All right. So it looks like we didn't crash. Big win for us. And so let's go in here and try to, you know, go get a little farther. We'll now make the current context current, which actually means that we're kind of on to a new segment. That was quick. That was quick. eglMakeCurrent. That's the next thing. So let's see it. Run it, upload it, hit it. Okay, we're getting some assertions. Very nice. Context.c 608. Okay. So where's this coming from? CTX const program this max texture image units. Okay, sure. So what is this? Core driver constants. Okay. Sure. Can we look at what they do for like a no-op, for the no-op version of this thing? I think it was a no-op pipe. Create, context create. So we're looking for like the const, right? That's what this thing is, CTX. Wait, where was that const thing coming from? Yeah, where was that? Hold on, okay. CTX, so this is a GL context, not a pipe context. That's important. We should keep note of that. And where is this? I guess we need to find out where this is going to be assigned. So this is from max texture image units is equal to something. So everything's going off the edge of my screen, which makes this really fucking hard. Okay. Interesting. So how... Surely this would be done on like initialization, right? If we looked for this like const thing. So this is on... Okay, hold on. Ooh. Mesa init constants. This sounds likely. The API here is a GL API. Okay. And all of this looks like they're setting the things that they were checking, right? Like max texture image units. So where is this called from? Get version. As well as, yeah, get version feels like the right spot. Okay. Get version is called with a screen. We give him one of these. Oh, so maybe he's like reassigning these things? Maybe. That's possible. Definitely possible. Okay, yeah, consts here is a GL constants passed in here. Okay, this seems likely. This seems likely. Dronic. Thanks for the prime. Much appreciated. Much appreciated. So, what was the assertion on? I already forgot. It was on. Let's check. It would be in this. Max texture image units. Max texture image units. And it was on mesa shader fragment. So can we look for like max image max texture image unit. So there's a lot of this stuff, which kind of implies that this stuff has been set before this. Oh, here we go. PC. What is PC here? Oh, for each shader type, we call get shader param with the shader type. Okay. So that's probably in here. We probably need to handle this. So I guess we will start with, if our shader is of a certain type, what was it we wanted to fix? The fragment shader initially? Case pipe shader fragment. Okay. Which then follows with a break. Default break. And then we say we switch on the param, right? Oh my god, this fucking indentation, man. Switch on param. And here we have case. It was like, fuck. This thing. So here, I guess we just, oh my god. Return 1. I hate whatever indenting is happening here. It's gonna make me lose my mind, but it's fine. Default break. All right. So presumably this fixes that exactly one problem. Oh, it actually does not crash at all anymore. That's the only thing that was failing? Really? That's the only constraint we broke? That's actually shocking. That's pretty surprising. I expected us to have a lot more things to deal with. Which means that we are now at trying to do GL viewport. Let's see what happens. Let's just see what happens. So that works. Can we get all the way to the end? I guess we're not checking for errors, so if we don't crash, we're chilling. Yeah. Now, the confusing part is nothing will happen here. Right? So, like, what's supposed to, oh, here we go. Error. Invalid frame pop. Okay, wait, hold on. So let's try to get rid of like our log spam. That will probably help. Okay. Let's see if that reduces the amount of garbage we have to look at on our screen. Okay, here we go. So we have mesa error, invalid frame buffer operation in glClear, incomplete frame buffer. Okay. So I guess, where's that like num mesa modes things coming from? Num mesa nowhere? Hello? Didn't we? I remember seeing that somewhere. Oh, MSAA, sorry. Hello, are you emulating a GPU in software? That's probably where we'll eventually end up, yeah. Right now, we are forwarding calls to OpenGL a little bit. Even that, we're not really doing. But yeah, we probably will end up doing like the whole GPU in software is probably what we'll end up doing here. Okay, so I guess this probably is like our starting point here. So we'll kind of call this, we're looking at like glClear. What's going on here? So we need to look for, yeah, whatever this says. Mesa error in this. Mesa error. No. Error in dots glClear, maybe? Can we just like go into this? Incomplete frame buffer. Here we go. Okay. All right. Here we are. So we should just like double check this by setting a breakpoint in here just to make sure. This is GDB breakpoint at clear.c177. Hopefully this will actually load. Yeah, okay. And then we hit next and we get the error. Okay, cool. So we're at the right spot. It's here. Now the question is how the fuck does this get set? Where the fuck are we, right? I don't really know. We're in this function called clear in mesa main clear.c. So I guess we could hit run again and hit the backtrace, kind of figure that out. So we're really just like ripping it here. Clear and mesa clear at the top level. Interesting. So I guess it has probably to do with the initialization of the draw buffer, right? It looks like what we're seeing here is that like typical, like by default, you are probably rendering to some buffer by like just some buffer somewhere, right? And probably that's supposed to be set up by your like eglContext creation, I would bet. So this context is a glContext. Okay, I guess we should look at the assignment of draw buffer equals or something. This is not very good. It kind of implies that there are no real good matches to this. Okay. What is this? This is of type GL frame buffer. This is of type GL frame buffer, and I guess we should probably look for some sort of like GL context initialization, right? Which we had somewhere. Context.c. Mesa initialize context. Okay, so this is just referencing a frame buffer. Somewhere they must like set this thing, right? Here they set it to null on initialization, which feels kind of fucking weird. But I guess maybe you create the draw buffer somehow. Let's actually double check here. If we call test app dev dri card 0, We do not see that log, which implies that the draw buffer does work correctly there. Hey, yo, what's up, what's up, what's up? What's up, what's up, what's up? So, someone has to set this thing. I wish I could kind of see more in this like reference view. But we could maybe start like looking for people who use this as a pointer. He's already a pointer though. Yeah, so somebody must either assign him or take him in by reference for like a double pointer. So maybe we look for like usages of like struct GL frame buffer star star. Which really just comes from mesa reference frame buffer. So where do we see this? On like context initialization here. Okay, so they assign this thing by doing that, right? So they say right, this does like some reference counting stuff, some assignment stuff. Okay, cool. So this is probably the call we're looking for. So where we saw like, there we go, maybe we go here. So mesa make current or bind frame buffers, which is just make current. Okay. Oh, unless the fucking, is this broken again? Yeah, it's fucking broken again. That's so annoying. Oh, I hate that. Okay, I'm gonna have to debug that off stream, but. So our call tree is a no-go. Call tree is a no-go. Okay. So I forget, there was some sort of like major mesa init function that we ran at some point, right? Context init probably. Context init. Init. Mesa initialize context. Right, and we were looking for usages of the draw buffer in this function, which we don't see. But what if we do mesa initialize? So this doesn't take in the context. Okay, we're gonna poke around a little further. Okay, let's go back to whatever that function was called. What was it? Mesa reference frame buffer with the draw buffer. Okay, let's start in context. It feels like that makes sense. So this is on mesa make current, right? And so here on make current, they say if the new context draw buffer is not available, which I assume is going to be the case for us, right? We're going to be in this like nulled out thing. Then we would like to assign this thing from the draw buffer, which means that the draw buffer needs to come from somewhere, right? Just like hand wavy. You know, so like these are null. So fuck those. This is a assignment. So it's like probably like here somewhere. This feels like the most likely place. I don't really know what ST is. State manager. Make this thing current. Okay. So let's just do the stupid thing and check if we ever call this function. So this is st manager manager.c line. It was here we're looking at 1154, right? And then we want to run with dev dri card 0, not our driver, to see if that ever happens, which it doesn't, right? So we shouldn't be expected that when it doesn't have for card 1 either. I think that makes sense. Now, the question becomes is then why we must have guessed wrong. We must have guessed wrong about where this thing gets assigned. Wait, can we go into mesa make current actually? Can we go into here? 1477 and run dev dri card 0. Does this get hit? No. Interesting. I would have guessed that this was it. Can we go into like We were in clear.c. Clear.c was the bad boy here. This is where our error is starting from. Maybe we want to look for where this status gets set. Frame buffer, FB object, draw pics. Draw buffer is showing up in some of these, but not assignment. Yeah, it seems like the draw buffer must at some point get assigned somehow. I'm missing where. We're missing where. So not in ST manager. I guess maybe we could like somehow. This is where like reverse debugging would probably be very helpful, but I've never really set that up. I'm just trying to think. I guess we kind of just really glossed over eglMakeCurrent, right? We didn't really understand what was happening there. Which might be useful in some way. So can we like... Okay, so there's a lot of stuff about draw surface in here. Hold on. Can we breakpoint here? So this is in eglAPI.c line 930. So if we look with card 0, the working version, can we like print draw surf? That's null. Okay. So then we are probably going to get down here. I guess we're just hitting X a few times. 946. 954. Okay, so he gets in here. 960. It's like kind of down here. Okay, so at this point, the draw surface or the read surface should not be set. So then all the way down here, I guess... Right, like this stuff kind of implies that draw surface is not set at 969, 976. Okay, so P draw surf. Yeah, this is still null, which makes this seem a little sketchy, right? Because this does like a dereference of the draw surface. What the fuck am I looking at here? So for EGL resources equal to null and all of our arguments, we set a double pointer to this thing. So he's probably like null checking each of these things, right? This is probably a way for him to dereference these things automatically. He like locks some stuff. But like, oh no, this takes in resources. But I guess maybe he never makes it to these guys under some condition. For this thing, this is all in the for loop. This says the condition here, these are the inputs, right? Then here he probably iterates by 1 or something. Geez. Okay. Well, I mean, we know that this doesn't crash even though it's not set, right? So we can be at least somewhat correct here. Right, we're definitely passing in null here still. And I wonder if makeCurrent will set the draw surface. We could check maybe by hitting next here. We're at 980 now. 985. Okay. And where does like the draw surface come from? This comes from surf equals EGL surface surface. Oh, which was input is 0. Oh yeah, because we're using surfaceless drawing. That's true. That is true. So all of this was stupid because we passed in null here to begin with. So then the question is what happens in the happy path here? Can we look at like CTX, what is it, draw surface? Is that where this is? Why is he mad? Why is he mad? CTX, oh, because this is a void star? Is this where the draw surface is? No, certainly not. Certainly not. It was like kind of like a few levels down. Oh no, there is something here. There is this draw surface, which is probably not the same thing, but what was this thing called? It was called context draw surface. So this is null, even on the happy path. Okay. So interesting. I guess we want to go to where that error is in clear C. And can we like breakpoint here in the happy path? So this is like run dev dri card 0. Okay. Not this. Info breakpoints del 1 2 3. Okay, let's run again. Oh, we don't get here at all? But we do if we call dev dri card 1. Yeah, we do. Okay, that's interesting. Definitely interesting. So that means that this mesa clear is only called in like some fallback case, I guess. Right? Where is this like mesa clear? This is at clear.c 245. And you're telling me that in the fucking vergl case, this is just not called? That's interesting. That's super interesting. Right? Like we breakpoint at... Okay, then in that case, we should break at main in glClear, run dev dri card 0 and see where it goes. What the fuck? Can we break on glClear? Okay, here we go. Which is in libgl. So, okay, what is... Is there like a glClear anywhere in Mesa? Or is this some sort of like weird... like weird generated function or something? Like surely this like gets defined somewhere, right? Surely. We're seeing a lot of header files here. A lot of headers. And it's also strange, I guess, that we see like... there's a piece of the puzzle missing here for sure, where like we saw this go directly to Mesa Clear earlier. Right? Which is like, how the fuck does that happen? There must be some sort of like symbol aliasing, right? Because like this function, as far as I can tell, is, oh, okay, set clear. Okay, hold on. So this is called in mesa init dispatch. Is this like something that's called? Oopsies. Del 5 info br, del 4, del 6. My guess is no. My guess is that this isn't called init dispatch, right? Like, yeah, this is like not defined, so it makes me think that the library this is in doesn't end up getting called. Oh wait, no, okay, so this is getting called for card 1. What about for card 0? No, for card 0 this isn't called. So that's again kind of interesting, right? That like this st context thing we might be like somehow ending up in here when we wouldn't in the ver.gl path. And so the question is what is the difference? Right? Like do we end up here? So this is stmanager.c 956. Run dev dri card 0. So we're looking for card 1, I guess. We're looking for breakpoint 9. Give him a sec. Breakpoint 9. Okay, so we get hit with our card. But what about with their card? No. So we have to go even farther up the path. So this gets called on like eglCreateContext. Okay. Which is called by like eglCreateContext. Oh, I wonder if we have to force DRI. No, we are forcing DRI, I'm pretty sure. What about here? So run. Oh, fuck. Dev DRI card 0 and card 1. We should see breakpoint 10 hit first now on our driver implementation. Yes, we do. So all of this stuff just isn't getting called, which is crazy. It makes me think that we are not in the right path for card 0. Like there's something we don't understand, but that's okay. We'll get there. Can we like backtrace this thing? Where is he coming from? eglCreateContext, DRI2 create context, eglCreateContext. Okay. So can we go like maybe like up, break, and then run dev DRI card 0. Okay, b egl api.c. Where was it? 901. Del 11, r dev DRI card 0. Okay, so that's hit. Oh, eglCreateContext. Okay, let's look at there. EGL 901. So this calls display driver create context. And so then the question is like, where does this go? Okay, so this goes into eglDRI2. Which is at line 1488. What was our backtrace before again? It was create context to create context attributes. Which is what? Okay. So this was called. I'm confused again. I'm confused. We were at DRI utility 461. 461. Okay, so we were here. Where is this thing used? He could be called directly. or he could be called through this createContext function pointer. This is probably where we were here. Right here, 1562. Okay. And then does this just go somewhere different? P dri to dpi mesa createContext. Okay. And can we like, what is at this? He doesn't know. That's that makes sense. But I guess we could just step into this. Who ends up at here? Wait, fuck. What are our other options? I mean, our options are all dri create context attributes, every single one, right? So how is it possible that we don't end up in here? Unless I misread. Can we del 7, 8, 9, 10, 12, 13? Okay. So we'll confirm that with our graphics card or with our driver, it does end up there. Okay, and with theirs, it doesn't. So I don't understand how that's possible. Because we see that he ends up here with this createContext call at 1562. Right, we run with that, we hit it. So then I step here, and he immediately steps over to this line. So he doesn't end up in there, which is annoying. So maybe we just kind of change our breakpoint. EGL dri2.c, and we go to like 1558 or something, just to get it to breakpoint earlier. I guess. So he's in fill context attributes, finish that. Step, step, step. Yeah, so I don't understand how he doesn't end up inside this function. Right, we're seeing him like 1562, 1565, which is here. Like when I step, shouldn't I end up in this function? Like what the fuck is going on? What's going on there? I guess we could be in DRI software. But this is the same function, right? DRI create context attributes. There aren't like two definitions of this, are there? One in driutil.h, one in driutil.c. Yeah. It's all the same. It's all the same. So I don't understand how in some cases we're not hitting this breakpoint. Unless this is in a libgallium that we haven't got debug symbols for. That's actually kind of likely. That's pretty likely, actually. Because our build process here is to copy libgallium drm dri.so to our GPU implementation, which kind of implies that we should be copying it to their implementation as well. Yeah, I'll bet you that's it. Is that the debug symbols just aren't there for libgallium. Because what happens is they like hard link this shared object to all the different driver names that it could match against. Okay, so let's just change our build line a little bit. So this line where we copy our new version of libgallium that has debug symbols, we do this twice, but once to vert io gpu dri.so. I think that's what it's called. Yeah. Hopefully that gets us a little bit more info. Okay. So in this function, we were break gdb, this thing, break at driutil.c461. Okay. Run dev dri card 0. give it a sec. He's thinking. There we go. Okay. So there actually was no difference there. Okay, so now let's go back to whatever the fuck we were actually trying to debug here. It was in mesa clear, right? We wanted to see if they call this in the happy path, in the case where we were using the other driver, the one that works. Let's see. Much better. Okay. Everything's making way more sense now. Way more sense. So we thought that because our breakpoints weren't getting hit, that the working driver for vert.io GPU was not calling the same functions as us. That was a bad conclusion, right? What actually happened was that we forgot to update the shared object for that driver, which meant that it had no debug symbols, and so our breakpoints just couldn't get hit, even though that code was running. Which is pretty cool. Okay. So all of this was us trying to figure out. Was it this one? No, it was incomplete. This. We're trying to figure out why this is getting hit, right? So we wanted to breakpoint at line 176. Hit continue and see what this looks like on the happy path, right? So we have no error is false, right? So this is true. So they are accepting errors. And if we look at CTX draw buffer status, we see 0. Which is actually not that, huh? So now we're 177. Oh, wait, hold on. Test app dev DRI card 0. Is this failing? Oh, wait, we're seeing the same error. So our test case is just fucking stupid. Oh, because we're using surfaceless rendering. We're idiots, of course. So the reason we set up with surfaceless rendering initially was because we were copying this test case where we were trying to render to a frame buffer. How do I explain this? We were trying to render to a frame buffer and then copy that frame buffer to a Wayland compositor. That is not the case here. So it makes sense. Both of these guys are complaining about the same thing. They're like, you don't have a frame buffer to render to, because we would usually set that up manually. So we could either set that up manually or try not to do that. Let's try not to do that. So can we fix this make current call? So let's look at like what a different application would do. How do we do this? Probably KMS cube is probably our best reference here. Let's go look at that. Build root hosts. Nope. Build KMS cube. So can we just like look for like a eglCreateContext initialize in here? So they initialize, then they choose a config, they create context, and they create window surface with the GBM surface here, where GBM is a struct GBM, which comes from the KMS cube. So the surface is a GBM surface here, which comes from GBM surface create here. So they just cast like this. Okay, so we should be able to do the same thing. So we do, we have our GBM surface created with GBM create surface. So it should be just like, const egl surface is egl create window surface from the display given our config, right? As well as our GBM surface, which we call GBM display like a fucking dumbass, right? And null. Okay. And then we make current with that thing. So this is an EGL surface here and here. There we go. That makes a lot more sense. All right. So let's try to run this with card 0 and see if he like gets mad. He gets mad at build because we don't have create window surface. Did we spell it wrong? surface. Much better. Much better. Watching you test stuff, I should honestly test what I write more. I mean, for us, it's really just because we can't write code that works, right? It's really more that my testing is actually, I think, not very good, but we do our best. We do our best. I think that like breaking down problems into smaller problems is pretty helpful. Pretty helpful. So he's still complaining about the same thing, which means that this was not sufficient. It's kind of surprising. It's kind of annoying, to be honest. I guess here we should check if egl surface is equal to c egl no surface. Here we say return error create surface. Let's kind of start here. What's he pissed off about? I fucking spelled surface wrong. Okay, so this is failing. That makes sense. So why would that be? Why would that be? Let's do, oh, actually, I think that, like, if we run kmscube right now with dev dri card 0, does that work? No. Okay, I think it's because this thing we have to click this button once first in order for this to work. No? Whoa, hold on. This is new to me. Because up until now, kmscube has like pretty reliably worked for us. But I guess that was before we rebuilt Mesa. So maybe our rebuild is like fucking broken. Let's just also try restarting the virtual machine, just in case like we're in some sort of like shitty state that we ended up in. All right. Okay, so we initialize this plate, we run root kmscube dev dri card 0. Sorry, with -d. Yeah, he's failing to choose a config. So if we go to like cd dev dri or user, what was it? User lib dri, I think. Okay, so we should have. These guys are all using the same library, which is kind of surprising also because we only updated half of them. Right? We call like lib gallium dri to user lib dri vert io. So we never updated software rast or KMS software rast. So why are all of these guys getting the same SHA sum? That's a little concerning. Oh, actually, it's because these are all hard linked together. I forgot. I forgot that these are hard linked, which means that it's fucking broken. Okay, let's try getting our build of Mesa out of there. Right, we've probably done something fucking stupid. So I run back to build root and I just type make here. I believe that will reset everything into like the state of whatever build root has, which does have some mods that we made to Mesa because we're idiots. But we can at least like break down the problem here and see if at least that like kmscube will run if we do that, because it used to. It used to. So what we should see now is if we look at the rootfs, we should not see our like Sphero GPU driver exist. So we look at like dev dri. Sorry, it's user lib dri. Yeah, no Sphero dri. That's really good. And so if we run kmscube now, no connected connector. So here we need to click on this so that he gets a connected connector, and then we run this. Okay, so this works. This works. That's a good sign. That's a good sign. So we have a working state somewhere. Now let's kill this and then go back and do our own internal Mesa build. So let's say that we turn on our networking. We need to delete our stashed keys because our SSH keys have been regenerated with the new file system. Oh, fuck. I actually don't want to run test app here. I want to see what happens if we don't do that part. So we just copy all the libraries over. Nothing crazy. Nothing crazy. Right, we Then we run kmscube again. Okay. That's interesting. So we, I feel like, have not made many mods to EGL. Nothing that I feel like should impact this. Oh, that would do it, huh? That would do it. Yeah, we did remove a bunch of things. I thought that I backed that out. All right, so let's undo our changes to DRI screen. Let's back out these changes. And let's try again. Whoopies. All right. There we go. We're so back, baby. All right, we're back. KMS Cube, doing the right thing. Big win for us. So now we can start running test app again. Compare that. Zig build and SCP and connection refused. Why? Oh, because I killed the VM by mistake? Oops. Oopsies. My bad. My bad. I didn't think they were paying attention like that, you know? Thought I could kind of like pull that thing up from behind your back. For the stuff you do, how decent a PC would you need to run VM without slowdown? I mean, the VM will only do as much work as you asked it to. So we're not really asking the VM to do much work. So it's fine. My computer's not very new. I'm like maybe like 5 years old for most of the components. Maybe older. I know it was a long time because I bought a new CPU to play Fortnite. Which, that was definitely a long time ago. All right. Okay, so this is still failing with create surface. However, oh, this is also not working. Hold on, hold on. I forgot to click this button. That's a very important part of this process. So KMS Cube running, test app, still failing to create surface. Okay, so our test setup is just invalid in some way, shape, or form. So we probably want to look at what KMS Cube is doing to pick its EGL context a little better. It probably is asking for some attributes that we are not. And that is probably relevant in some way, shape, or form. Build root, build, KMS Cube. Let's see what they're asking for. EGL create context. Create window surface, choose config. So what the fuck are they doing? They are calling EGL initialize. Are they passing in attributes here? They are. Or we are, sorry, we are. So they have config attributes here, which are these. I guess we might as well slap these here. You know, we can try them. We can try them for sure. We you know, this might help, So Yankees, where samples is kind of passed in, whereas samples taken one of these. Samples is passed in as 0 initially, I guess. Unless we have an argument on the command line, so we can just pass in zeros there. Where the fuck were we? I'm lost. Here's where it was. Okay. So we just kind of copy all this. Yoinkies. OpenGL bit I'm fine with. And we're just gonna go under here and kind of put a C dot in front of everything. Boom. Yeah, like this, and then write a 0 here, I guess. I don't think that this will fix our problem, but we want to get a little closer, so let's see. Yeah, so he still fails to create a service. That makes sense. Probably because their config choice here has to do with like match config to visual. So they're looking for this on each config. That's what they're doing. I guess we could also run KMS cube on our thing and see where it falls over. Yeah, so he's saying no EGL configs with the appropriate attributes. No EGL configs with the appropriate attributes. Okay. Okay. So do we have the same problem here? Maybe. Okay. So card 0 is chilling with KMS cube. And so we should start by making sure that getting KMS cube to work you're running choose config with our test app on card 0 will do what we expect, and it doesn't, right? So GBM DPY is a GBM service, not a GBM device, not a GBM service. Did I really just fuck that up so blatantly? Yeah, you're right. I definitely did. Thank you. So where does this thing come from? GBM service create. Thank you. That is amazing. You just saved me a bunch of time. Thank you. Thank you, thank you, thank you. Where is this like width and height coming from? Init GBM width and height, where they have the mode HDisplay and VDisplay. Okay. So we'll try this first and see how that falls over. GBM surface create. Format. Where does this come from? Format equals format, where format comes from init GBM, which comes from the probably DRM format. Okay, we'll just copy this. That's fine. Which comes from lib DRM, DRM4CC, boom. Okay. And then we have init surface here. I guess we just pass this. I don't know. BO use scan out and GBM BO use rendering. I don't know, man. Did I spell service wrong? GBM, GPM, boom. There we go. All right, does that work a little better for us? He still fails. Still fails. Sucks. Sucks. Okay, we're thinking. EGL create window surface. So they do call this with GBM surface, which is type GBM surface, which should be what we have. Yeah, this is a pointer. So the pointer, they're both the same. They're the same. I think likely that like EGL choose config stuff, this is certainly going to be important. Maybe. So here they just, if visual ID isn't passed, what happened? Where is this? So visual ID is the third parameter here. Okay. Which is an EGL int. So here they're checking if this is not 0, which it probably isn't. Because here they're coming from GBM format, where format was given to us by like this thing, right? Where format was presumably this. So since this is non-zero, they're looking for, they're basically iterating over all of the configs and checking if they can use that here. That makes sense. That makes sense. So we're gonna go like, first we need to allocate the right number of configs. Here we say like, yo, let me write this into something that's right. So they call EGL get configs with the number of configs, right? So they say like, let me use this display. Let me go null. Let me go 0 and tell me how many there are. Like this, right? If this is not equal to C EGL true, we return error get configs. Okay. Then here we need to allocate a list of configs. So I guess we need an allocator. Var GPOs stood keep general purpose allocator with I don't give a fuck arguments. We deinit that thing later and we say const alloc is gpa.allocator, get our generic interface out of this. Then we can call alloc and we want EGL configs. Oopsies, it's EGL config like this. And we want num configs of them. Right, we want to do something like this. Okay, which then lets us pass in here configs pointer, configs len. And then we should be able to iterate over these things. So we should be able to say like stood debug assert configs len is equal to num configs. We should be expecting those to be equal at this point. And then we should be able to iterate them all. For configs, it's something like this. We should be able to call C EGL get config attrib with our display and our config. We're looking for EGL native visual ID, and we want to know what the ID is, so ID. So we're gonna have like var ID is a probably C EGL int or something. Probably. Whatever, I'll just slap this in like this for now. What does it mean config is shadowing under scope? There's no config variable anywhere else in this. Oh, there is here. It's fine. We can just delete that. It's not used. It's not used. We say if ID is equal to, you know, that XRGB shit. Break. And we want to break I or something. So we want to do like var I equals 0. And then like, can we do like this? How do we want to do this? When we call choose config, config out here, they call. So egl choose config gives us a config out. And then eglCreateContext with that config, right? Yeah. So here we need like I guess we will make a function for this. I don't know, man. I don't know. This is going to be like a slice of C egl configs. I think that this is going to return a C egl config, probably, right? And he's just going to return config, which means that we don't need like index tracking like they were doing. Oh, we also need the display. Okay. And then if we get to the end of this, we return null or something. Right? I don't know, man. Which means that we can call like const configs, you'll choose config with display and configs. Boom. Should be something like that. Or else return error no good config. Okay. Does that work? Obviously he doesn't work because 74, he wants this to be int cast like this. We need a usize, they give us an int, and then we have configs len here at 76. I guess we'll cast that as well. And then egl int does not exist. So maybe they just want like a cint. I don't know, man. I don't know. Get config attributes. So if this is not equal to egl true, we'll say return error failed to get attribute. Is that what this thing does down here? What do they do? What do they do? They just skip it. I guess we will do the same. Okay, panic unreachable code. Super cool. Main.zig 82. Oh, here. Stood debug print. Num configs is this, and configs len is this. What is going on here? What is going on? Because I thought... Oh, I guess because we are filtering by some attribute. So this is just like fucking stupid. So we should kind of like sub-slice this thing. This is like max configs. Right? And then here we have like const configs, you'll max configs from 0 to the actual number of configs that matched our filters. I believe that makes sense. Okay, so that actually looks like it succeeded. We actually got all the way to the bottom here. He said, "Hi, Mom, we are finished." So now we should be able to go test app dev dri card 0. He is chilling other than the fucking leak keys, so I guess we should just fix that because it's fucking annoying. Defer alloc free max configs. Are we sure it's the first num configs that are matched? I think that what happens here is that like this tells us how many are available to us, like how many could match potentially. Then we allocate an array with that thing, tell it that that's like how many that we could get, and ask it to tell us how many it actually returned. I'm like 80% sure that's correct. Like 80%. Okay, wait, hold on. So, oh yeah, right, that sounds reasonable. Yeah, I mean, I didn't read the docs. We're kind of just guessing, but, you know, probably good enough. So now we're seeing no good config, which makes a lot of sense, right? We never really set up EGL configurations in any way. And now it's claiming like, yo, what the fuck? I guess we did have at least one before. What did we end up doing? We didn't end up doing xbgr or abgr or something. I think we had to pick something. Can we print out what configs we have? That might be useful, huh? So let's go into this like config selection. Wherever the fuck we do that. And can we just print out you know, ID has this ID, right? Let's just start here. So card 0, bunch of fucking options. Card 1, one option. Okay, so our one option, I would bet is something that we hard coded the other day. So can we look at what these definitions are? 4cc code. So if I remember correctly, this is like an int cast. We can do something like extract each byte of this and print it as a character. And I think that that gives us like a chunk of letters we can look at. So we can do like we can do something like, I don't know, for 0 to 4, we do like the ID. Okay, so if this is little endian, then that means the lowest byte is first, which means that we want to go for while I is greater than 0. We want to kind of go the other way. And we want to var I equals 4, like this, right? And we want to do like a std debug print of like the character that is encoded by ID shifted right by 8 times I. No, we want to go up, right? Lowest byte first. Yeah. 4, 0 to 4. Okay. So we start at 4, which means that this gets shifted right by none, and we just mask this into a truncate. Right? I think that makes sense. And we probably have to do like as U8 or something here as well. That sounds right to me. And we'll do like ID like this. And then we print a new line at the end. All right, let's see what that does. 2 bytes? Okay, well, now that you've said it, I sound like a fucking idiot. But now it's too late. We've already done it, so we might as well finish. Expected unsigned integer type as E32. We've already done it, so now we have to just live with our actions. So AR24 is our one option, and on card 0 we see like a bunch of these. XR30, AR30, XR24. Okay. So can we look at like this code is XR24, and we only support AR24. So we did ARGB 88888. So can we, I think that this is something that we did intentionally. This sounds really familiar, right? If we look at Sphero DRM Winsys in our Mesa implementation, we have this as our only option, right? So can we just change this to BGRX as well? So we actually don't need to check it here. At this point, if we have returned false, it's implied here this is the right thing. And then we can say if format is not equal to this, and it's not equal to pipe format BGRX8888 unorm. And then we do build.sh and all this stuff. So now I'm hoping to see two options for matched configs. We do test app dev dri card 0. Or sorry, card 1. Card 1. We still only see XR24. That's unfortunate. That's unfortunate. I was hoping to see two. But I'm also seeing a seg fault. I'm also seeing a seg fault, and that feels new. I'm not gonna lie, that feels new. So can we see where that's coming from? It could be that this is now we need to implement more things for some part of Mesa to support this alpha-less thing. You know? How are we doing today? Not bad, not bad. How are you? Why is it taking a year to read symbols? What the fuck is going on? Why can't I get out? Can I SSH in? I can. Can I just kill -9 306 in here? Yeah, I can. Okay. Weird. Yeah, I don't understand what's happening here. Very strange. Very strange. This GDB thing is fucked. Oh, there we go. Weird. Alright. I should be SSHing in all the time. It's way nicer to read it here. Okay. Yeah, so this is in makeCurrent. Oh, nice. Okay, wait. This means that we found a configuration that we're happy with when we're using our thing now. But DRI2 create image common is just not working correctly. Which is probably just some fucking unused thing. So can we go to here? DRI2 1308. Here we go. Here we go. This is just a thing that we haven't implemented. So this is on pipe screen. Nice, guys, we're getting farther, kind of. We've kind of gone backwards, but we're going forwards by going backwards, you know? So let's see what happens. Let's see what happens. What is this supposed to do? Who knows? But we'll find out. Kind of, maybe. No guarantees. Okay, so this takes in a screen. I guess we should follow their behavior. I kind of like the pointer being on the type, but I guess it's kind of they're putting it on the value, and it kind of makes more sense. Because, if you do int x star y, I think that this makes a pointer to an int at y and a int at x. Yeah, right? So the star really does belong to the value, the name of the variable, not to the type, which is kind of confusing, but it is what it is. Can we look at who else implements this resource create thing? Surely we can use our typical VirGL reference. I guess this probably actually does some sort of kernel allocation, huh? I guess it probably does. Yeah. So I bet this is off rip. This is the first time where we're going to have to try to interact with our kernel driver. Can we look at the software implementation of this thing? What's Noop do? Malik's. Yeah. So what I kind of want to do initially is I kind of want to skip actual working with the GPU temporarily just to see how far we can get, right? Because a glClear, we could do this all in software at first, just to figure out the Mesa APIs, then figure out how to hook it up to the GPU later. That seems kind of nice to me. Seems kind of nice. So really, all we have to do is make one of these pipe resources. Okay, okay. And they have some sort of like template that comes in, which is, I guess, you're trying to like copy some resource, right, in some way, shape, or form. Okay. So what's an N resource here? A Noop resource. And then B is probably base here. Threaded resource, B. Pipe resource, B. Cool. So they're just copying this motherfucker and then allocating data for him. Right. So this is kind of like a concrete implementation of the pipe resource API. They have this like size and data that they're creating. So we can probably cheat a lot here initially. I would like to see just I guess we'll find out pretty quick that somebody else uses them. So I think for now, all I'm gonna do is just create a new one of these and return him. I think that's what I'm gonna do for now. That will kind of skip all of the like concrete implementation details, but we can skip those until we need them, right? So we kind of just want to do like, you know, calc struct pipe resource, right? And we'll say struct pipe resource star ret is equal to this. We just say star ret is equal to template. Return ret. So he doesn't like this because pipe resource is maybe not fully defined yet. Okay, he's much happier now, and I'm much happier now that I think that this will work. Root at localhost test app dev dri card1, right? That's what we're testing, I think, if I remember correctly. Copy all of the new shit over, which takes fucking forever. And we still segfault. Okay, so can we GDB? R dev dri card1. I assume that this fixed a segfault and we're just now in a different segfault. That's my guess. So we are in DRI2 1492 now. Yep. Wait. Because the texture needs a screen with him now. Right, so this texture that we're creating is supposed to have a pipe screen associated with him. So that means that we, in Sphero, DRM Winsys, or whatever, we need to say that ret screen is equal to screen. Easy fix. Easy fix. Let's see it. Okay, new segfault just dropped. Stupid, but it's okay. Run dev dri card1. Backtrace. We are at 1438 now. dri2.c. Oopsies, wrong one. There we go. Resource get handle, which I assume we haven't implemented. So get a Winsys handle from a texture. Some platforms Winsys require the texture is created with a special usage flag like this. The context parameter can optionally be used to flush the resource and the context to make sure that the resource is coherent with whatever user will use it. Some drivers may also use this context to convert the resource into a format compatible. Okay, blah, 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 blah. So presumably, this thing needs to succeed, right? We're gonna kind of hand wavy guess that, right? Now, his usage of this function, wherever the fuck that was, resource get handle, this kind of implies that this W handle thing needs to come out. Ah, okay. So this isn't, we can just probably cheat in some way, shape, or form here, right? Right? Okay. So we're gonna call, what is it? Screen DRM resource get handle, not DRM. Okay. So we're calling resource get handle. Resource get handle, which means that we need to implement this. Should be straightforward, maybe. I don't know. I'm making stuff up as we go. Sphere DRM resource get handle. All right, and what are we gonna do here? We just have to return true, right? Obviously, to succeed. This is our screen, and we're gonna have to populate this handle stuff. So, dude, I don't fucking know, man. Okay. Handle type is going to be WinSys handle type shared. I think probably makes the most sense for like shared memory would be my guess. I don't fucking know. Layer input for a resource get handle. Like 0. Can we just like 0 out this shit? Right? Kind of like 0 that bad boy out, then set anything we care about. But maybe we don't care about anything yet. I guess we should see where we were called from and just set the parameters they give a shit about. So they're looking at stride, offset, handle, if it's a handle, but it's not. So our handle can be nothing. This looks a lot like the stuff we did when we worked with DRI prime. Right? This just looks kind of familiar. So I guess this is kind of assuming that we have some sort of way to share memory for a texture between processes, right? I guess that's kind of what they're getting at here, right? When we look at the options for the output type, to select handle for KMS, F-link, or prime, right? So I guess valid, input for resource from handle. This is an input. Oh, okay. Okay. So that means that whoever calls this in DRI2 so we are probably doing some sort of like KMS rendering. And he's trying to get a handle for something that we can do KMS rendering with, which I guess would be typically like the dumb buffer allocated. You would do like a dumb buffer allocation, right? Like we did in the in our raw dogging Linux video, where we create a buffer that's attached to a frame buffer. We would probably return that. And we would probably return it as a file descriptor. But what if we just don't, right? If we want to do everything in software temporarily, just like render to a file or something, maybe we could dodge this. Maybe, to simplify things. All right. Input to resource from handle, output for resource get handle. Right, so our output is the handle. So I guess we shouldn't just 0 them out. That's bad. We shouldn't do this. This is fucked up. Instead, we should just set the things that he says are outputs. which are just basically the parameters. Okay, I think I'm understanding. So we need to set the stride, which is just going to be the texture, width. Oh, fuck. Width times 4. We have the handle, which for now we're just going to set as like 0 or something. I don't know. We'll figure that shit out later. We're going to set the offset at 0 or something. Okay. We might have to do like a dumb buffer mapping here, actually. It sounds a lot like that's what they want, but we'll see. This is going to come from like the texture format, I assume. Is that like a thing that we have access to anywhere? Format here. So can we just do like text format? Like, I don't know, man. And modifier. And is modifier 2 on here? No. Okay. Size. Text width 0 times text height 0 times 4. I don't know, man. Maybe. So this looks a lot like the parameters we used for DMA buff transfers, just for the record. We've seen this before in like the Wayland client stuff. We have seen this before in the Wayland client stuff, but let's just do this, see what happens. Let's just see what happens, you know? Give him a sec to upload hundreds of megabytes of data. Okay. Pipe reference described in uinlines.h83. Okay, so pipe reference described. He has this. So presumably somewhere we are supposed to bump this. Do we have that anywhere here? Pipe reference. Pipe reference is just a count here. Confusing. Confusing, but I guess we'll just kind of figure it out with GDB, our best friend. So first of all, let's just test that dev DRI card 0. Everything's still hunky-dory over there. Right, dev DRI card 0 works great. Card 1, not so great. R driver, always broken. Shocker. Okay, so this is coming from like allocate textures at dri2.c 586. So we are trying to we're trying to reference the texture, right? So oh, that's this thing. Okay, so how does a count end up related to this thing? So we have source reference this thing. So we are supposed to initialize the reference count somehow, which I think we saw being done in the no-op version of this thing. I think. In like resource create maybe in new op. New op, bop, bop, new op. Yeah, here we saw this, right? Pipe reference in it. So we'll just copy this. We will copy this into our initialization here. Boom. This is just a ret reference here. And pipe reference in it must come from somewhere. So this comes from uinlines. Util uinlines. All right. And we just run it again, I guess. Step by step. All right, it's like, well, let's see it. Oopsies. Run with dev DRI card 1, the broken one. Our card. Our card's always broken. Their card's always fine. Backtrace. So this is now at makeCurrent at SC Manager 274. Create surface. So we just haven't implemented this, right? Yeah, we haven't. Okay. So what does this fucking thing do? Pipe surface is like a thing that has like a texture, a format, some references, context, a width and height. All right. I mean, it doesn't sound too crazy. What do they do in the not version? They literally just like copy all this stuff. Right? We almost want to just copy this like fucking like letter for letter. This seems like perfect. To be honest, this feels great. Actually, can I like... No, it would be cool if we could just like yoinkies their versions. It'd be kind of nice, but I guess that's not the play. I guess maybe we could like create a context for noob and use it when we can. Like if we did like an inner context creation of a noob context, no-op. I know it's not, but I like saying noob. Noob-op, noop, noob-op. Oh, but it's fine. It's fine. We'll just implement it as we go. It's fine. Sphero create surface. DRM, I think, has been our typical thing. Whoa, hold on. Is this in the wrong thing? Is this on the context? Holy fuck. Yes, this is on the context. So I guess we kind of want to call it like... Probably not Sphero DRM for the context. We probably want to call this like Sphero context create surface or something. I don't know. I don't know, man. Don't ask me. Sure. Fuck it. Fuck it. And I'm sure we're just gonna start seeing like tons of these segfaults, to be honest. That seems extremely likely. Extremely likely. Right, so now we're at set frame over CSO context. What was it? It was 794? Yeah. Right, so set frame buffer state, which is probably on the context. Yep. Sphero set frame buffer state. Can we just like ignore this? Like set frame buffer state, right? So this is supposed to be... I guess it makes sense to check the no-op version, but okay, yeah, can we look at that? I'm actually a little curious now. Yeah, this is nothing. Sick. We guessed right. We guessed right. Now, I'm sure that this has some meaning at some point for someone, but we just don't know what it is, so we don't have to think about it until we find a need for it. We do nothing. All right, ST clear. Wait, we're back in clear, baby. Let's go. We're almost there. We're almost there. Okay, 505. ST CB clear C. All right, wait, hold on. So this is clear in the context. So if we just go to clear somewhere, right, we have like CTX clear, right? Sphero CTX clear. This is probably the actual implementation of the thing we're trying to do. So let's fucking figure out what that does. Boom. Oopsies. So this is a Sphero CTX clear. And I guess we know that we must be in a pipe color union, right? We must be. And I don't know how we know for float or integer or what. That's a little confusing. We have some buffers that we're trying to clear. Okay. Scissor state must tell us where the bounds of the clear area are. Okay, that makes sense. I don't know what depth is here. This is probably telling us when we clear, we are clearing like this is the value for depth that we're clearing, as well as the value for the color that we're clearing, as well as like whatever the fuck this stencil thing is. That all makes sense so far. It's just this buffers thing I'm less clear on. But I mean, first we should check. I think that if that my guess here is that if we run this now, we won't crash. We will just do nothing of value. Yeah. Wait, that's super sick. That's super sick. So how do we know like what segment of the union we have in here? Let's kind of find the collar of this thing. So where were we? We were in like ST clear, right? So this clear color is a GL color union. How are we supposed to know? How are we supposed to know? So I guess the bright side here is that all of these have the same type size. So we have some luck there. Buffers probably holds the analogs of color buffer bit and depth buffer bit, etc. That's a good guess for sure. Clear buffers. Looks like it, huh? Yeah. Looks very likely. Now, what I'm then in that case, I'm still confused. First of all, I didn't even know you could set integer colors, right? So let's see OpenGL GL color, like, is there an option? Oh, you can do GL color 3i. Okay. Okay. So I guess maybe you could mark somewhere on like the output texture or something what the color, the clear type is. GL color is not GL clear color. That's a really good point. Thank you. God, it's so great to have you guys sit behind me and tell me this shit. Right, so GL clear color does seem to only have like floating point values here. In which case, maybe GL color union is just kind of used all over the place. Maybe, and like it doesn't have to be this way. Maybe we can assume that these are floats for now. I'm happy to assume that they're floats for now. I'm also happy to like, okay, so we'll say if, so this has to clear somewhere, right? Which means that like we must be going to our like draw buffer for the pipe context, right? That'd be my guess. What do they do on like noop clear? Oh, they do nothing because they don't do anything, right? It is no op. I should have seen that one coming. But what about like virgl clear? This is probably the useful place here. So they call a command clear that writes the unsigned integer color, which is kind of surprising, but maybe that's just like a type marshalling thing for the virgl encoder. That would make sense. Sure. So I guess like in their world, it's kind of like whatever frame buffer is bound right now, I guess, right? which I would guess comes from set frame buffer state. I'm kind of confused about how it knows the target. This seems like likely, right? Maybe. There's kind of like a possibility here that it's expected that when like binding a frame buffer is like a thing that you do in hardware, and then once you have that thing bound, then you can just kind of like do whatever the fuck you want, right? But I don't see any command. We haven't implemented any commands for binding a frame buffer, except for set frame buffer state. Set frame buffer state seems to be the most likely candidate here for us. Where we're supposed to track this really seems the most likely. But I just don't really see anything in here that tells us like a buffer ID, right? I guess pipe surface. Ah. Okay, wait, this seems kind of likely. So when we create our surface, we had the option here to like create this as like a member of some structure that would allow us to keep track of something, right? When we saw the new op create resource here, in the new create resource, they allocated a noop resource that has some extra data assigned to it, right? So this resource is the texture that gets assigned to, this is a, hold on. This returns a pipe resource, right? So when they call frame buffer set, we are looking for a surface that has a resource inside. So given this resource this texture pointer, we can figure out where we're supposed to draw. Yes. Okay. So in here, we're going to make a new structure. We're going to call this Pharaoh resource, right? And this is going to have like base, or like, we'll call it like pipe resource PR inside. And then we are going to have extra stuff associated with this, like, which is just a void star data, right? Now what we can do is we can, instead of creating a return pipe resource here, we're going to return a Pharaoh resource, kind of. We still have to return the pipe resource at the top level, but since this is the first element of ours, we can kind of cast between those things. Okay, it doesn't really make a difference. Doesn't make a difference. That's legal according to the C spec, which is a new understanding of mine. I actually didn't know that. So now we can assign the, the base class underneath, kind of everywhere we were doing this stuff. But now we just have this extra malloc we can do, which is going to be like sized appropriately. So it's going to be like malloc, like I'm assuming there's like ret PR width 0 times 4 times ret PR height 0. Right? We're going to do something like this. To give us 4 bytes per thing here. And then we return ret PR as an address. So now when we have our thing here on set frame buffer state, the assumption here must be that we have somewhere to stash this state, right? Hand wavy? That makes a lot of sense. So this is giving us a context. So when we create our context, we can do the same fucking trick, right? We can do like struct Pharaoh context is a struct with a pipe. Sorry, where is this context create? Here. Been writing too much zig. Types in the wrong spot. But here we'll do the same thing. So we'll say struct pipe context. PC, I guess we'll call it, for pipe context. Then here, all we're going to do right now is stash which color buffer texture we're rendering to or something. So we can do like struct pipe resource bound texture. Okay. This comes eglCreateContext. Since it's zeroed out, we don't actually have to set anything. It's just PC dot on all of these and return ctx.pc. Okay. Now, when we set frame buffer state, we bind that texture. So we say struct eglCreateContext is a just we can just do this essentially, right? And then we should be able to go like, oh, that means that this thing needs to be defined in a place where he knows that he exists. So let's define him up here. And then we can do bound texture as state cbuffs 0 texture. And here we need to do a manual cast. Right? I think that this makes sense. I think. Oh, so I did not put a pipe resource as the first member of n resource. It looked like it didn't to be, which seems weird. I'm down to look at that. Did not put a pipe resource as the first member of nr resource. So this was in create resource, right? Resource create. So they had this, they had this. Yeah, what are they doing here? That's a good point. I kind of assume they did. They have it's in threaded resource. So they have one more level of indirection, and we're just not handling threading correctly. Okay. So now we should be able to clear our specific texture. Right? We should be able to say that our in fact, we could actually stash this as a Sphero resource even. And we know that this is just a struct Sphero resource cast of the pipe resource. That should be fine, which means that now when we try to do a clear, we should be able to go for something like int I equals 0, I is less than the size of the texture that we have. So it's like, so we need our eglCreateContext. So this is going to be, we've been calling this PC around. We're going to have like struct eglCreateContext is equal to a struct eglCreateContext star of PC, right? We are going to be able to like look at our CTX bound texture, and we should just be able to like fucking rip the color buffer here. So I think we want to go like bound texture. What goes in here? PR. Okay. I don't know why it's not auto-completing here. Is this because this is lower? This is 111, this is 72. Yeah, so it should be defined here. Incomplete definition of Sphero resource. Ah, okay. Fine, we'll slap this up here too. Fine, fine. And we should be able to go like width 0 times bound texture PR height 0 times 4. I guess not times 4. For int I equals 0, I is less than this, plus I, right? So this is going to iterate all pixels in the display. We're ignoring the scissor state for now, right? We're just going to fucking clear the whole buffer. And we also have fix me which buffers ignored. We have like, you know, we're starting small. We're starting small. We're starting small. And now we should be able to just like rip this thing out. So we just go for, we already have the for loop. So we just look at the data. So we'll say like unit32t pixels is equal to, it's like the CTX bound texture data, right? This is even32 star pixels. And then we can just go pixels I is equal to color F times 255. Yeah, something like this, right? Pixels I. So can we do actually U and 8T star pixels? That will probably make things easier. We are going to have to like do something related to the format, right? But we are ignoring that for now. We're ignoring everything, right? We're just trying to get some evidence of something happening. And so we can do something like this. For int j is equal to 0, j is less than 4, plus plus j. We can do pixels I times 4 plus j is equal to color fj times 255. I think that gives us like a correct color value, I think. And what is the play now? I guess this is drawing to some buffer. And I guess like the ideal world, we like show this somewhere, right? That's kind of like the ideal, which I think probably comes from like an EGL swap buffers or something. Probably, right? I think that if like, let's try to get the red thing shown on the VirGL screen. So I think that means that in our test app, probably we probably want to do like CGL EGL swap buffers. I'm pretty sure this is what causes like the actual thing to get shown. And then we probably want to do like a while one stood times sleep and like 1 E9 or something, right? Just to like make sure that we don't actually leave anything. And so if we run this, he's mad because if this is not equal to EGL true or something, turn error swap buffers. He's mad because this should be while true in this language. That is a good point. Okay, so what we should see now is if we look at sphere this output, we should see red was what I was hoping. We see black, which is not really good. I was kind of hoping to see some form of red on here. Which is not good, not good. I thought this is how you do it. Can we do this in like a loop here? Quit PS aux script test app. Are we just running this multiple times at once? Test app dev dri card 0. Yeah, so this is not. I expected to see some sort of like rendering on this thing, which we are not seeing. Can we look at like KMSCube again as an example? How do they do their buffer swapping? Bump, 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 bump. Build root, build KMSCube. I thought it was like EGL swap buffers. Yeah, I mean, this is what they do, for sure. Okay. So I don't actually understand why this is a problem. To be honest, So here, what do? They set like clear, they clear it once, they clear color, then they run this legacy run function. They set up the CRTC. I guess we're not doing that, which probably doesn't help. We're probably skipping some sort of important initialization here, which kind of sucks. Yeah, probably what happens is they create surfaces for each of the EGL surfaces. They swap the buffers, and then they have to do some external management of DRM stuff to actually lock it up. Okay, well then I'm not going to go down that road right now because I think that's too much for what I'm trying to accomplish right this second. Instead, can we look at like what EGL swap buffers does for us? Because I just want to get some evidence that we have cleared a thing that we can look at down the line, right? So let's try to get EGL swap buffers working. Or we could call GL flush or something. GL flush feels like a better, like a fine place to do this. Let's do that instead. Because I think that like we haven't set up like multiple buffers or anything. This is the wrong fucking project. Let's do that. Let's go. Well, instead of doing this, we will call CGL flush and then return. Yeah. And then what we should do is when we see a GL flush, then we can say, oh, let's check that the color that we got is red there. That's, I think, a good end state for this. For this part of the project. Okay, so he's mad at stflush at stcbflush.c. Okay, so we go back over to our mesa stuff. stcb, nope. cbflush.c, and we look for flush, probably, which is calling pipe flush, which we don't have, so we probably have to go into this thing, and this is on pipe, right? This is pipe? No, this is context, I think. Pipe context, not pipe screen. Yeah. So here we go into our context, right? And here we will, where do we make this thing? Down here. We'll make a flush function. Okay. And this flush function will be like, here you go. And all I want to do here is look to see if we can see our bound texture have the right colors on it. Which means that we should be able to get our context out of this, right? And we should be able to just look at that and just say like, actually, is this supposed to return something? Let's look at the docs here. This guarantees that the new fence, if any, will finish in finite time. Subsequent operations on other contexts. Oh, sorry. So like fence, if not null, an old fence to unref transfer. So we can like just return null here on the fence, I think. And then here we will get, that means that we guarantee right now that everything's done. And so here we would like maybe like actually do the draw would be like one thing we could do here, but instead we will just check. We'll use it as a signal for ourselves to check if what we did is visible to us anyway. So we can look at like CTX bound texture data, and we can just say I is less than, whatever the fuck. This. Can we just like I want to just like print the color of the pixels here. Maybe like maybe we want to do like 2x. I guess we just do this once, right? So we do printf this with the color of the bound data at that point. So we have like this, and this is going to be pixels I times 4 plus j. Yep. And then printf new line. Okay. So if everything is gone correctly, we hope to see a spam print of basically all whatever color we use in glClear color. That's what we're hoping to see here. So let's give this guy a second to segmentation fault. Fuck my life. I really thought that would do it. I really thought that was the key. So this is at 134. Oh. If fence. I guess we do it like this. I guess we do it like that. Wait, did we get that right? If fence, yeah, we did get that right. We got it right. We got it right. Okay, so there's a spam of red, probably. That looks pretty good. That looks pretty good. And if we go back into our test app now and we change it to like do green or something. He says green now. Okay, so that's a really, really good sign. That's a really good sign. It looks to me like we have implemented something that looks about right for these guys, right? So what did we actually implement? That's actually like really unclear. But I think likely the on window creation or something. I'm not sure where the size of this thing comes in, but somewhere they call resource create, right? And they call resource create with this template with a width and a height kind of like defined. We take that and we malloc some an object, like a chunk of RAM that we can write into, and we stash that in like a Sphero resource for later. Then later they call I think it was set frame buffer. So later they call into us and they say, well, they also ask us to create surface at some point, but I think we just kind of ignored this. We kind of like bound, but I think though this means like a render surface, which is like maybe a little bit different than a texture. But for now, we're kind of ignoring that for now. And we just kind of set the surface to have all the same parameters as the texture that they created. Then eventually they call this like set frame buffer state thing. And they say, okay, this is what you're supposed to render to. And so this has things like, here are the color buffers, the Z buffer, and like, I don't know what the fuck this is, but you know, we'll figure it out at some point. And what we do is we kind of ignore this number of color buffers and we assume that whoever's calling us is calling us with one color buffer. We assign that to like our context, right? So now we have like some internal state that says, hey, we have this texture bound here, which means that when they call glClear here, we can use that texture that we wrote down and say, oh, if they're calling glClear, they must be writing to this thing that they asked us for. And then we call flush, we print all that things out, and we say, oh, we sure did write the color that we expected, which is pretty cool. That means that we have like all of the pieces of like the Mesa API that we need in order to implement glClear, which means that next stream, we can attach this, we can like connect this to our actual GPU, which is pretty fucking sick. That's pretty fucking sick, right? We don't need to implement anything more in the user space side in order for this code. Sorry, that was not really clear. We don't need to implement any more APIs to make this code actually use our GPU. We do have to adjust the implementations of all these functions that we wrote to make sure that they go to the right spot. But that is a problem for tomorrow. I am pretty excited by that. I think that we've kind of, this is like 2 days of just like chasing seg faults in Mesa. And that gets us to the point where we have a set of functions that we can use to like actually do some work, which is pretty fucking sick. So I think we call it there for today. It is 4:20, so blaze it, but it's a little bit late here. So I think we call it there. Thank you for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4:20 now, so you should just be able to see us online most days between 3 maybe like close to 4 hours ago and now. If you're new here, there's a YouTube link in the Twitch description where you can check out all of our previous projects. We organize them into playlists, so if you want to follow this demystifying Linux graphics stack, that's where that'll end up, but there's a lot of other stuff back here if you want to go check that out. There's a GitHub link in the Twitch description where the GPU testing environment will hold this code eventually, probably in a few days when it's a little bit cleaner, but we're getting pretty close to having something usable. If you're watching on YouTube, there's a Twitch link in the YouTube description. Swing by, say hi if you want, and you're online at the right times. What else? Like, subscribe, Twitch Prime. If you want to see kind of more of our like laid back section of the 12:32 segment, we call them happy hours. Those are on YouTube, kind of behind the join button. So if you want to see like some more laid back like reading or unit testing or like code cleanup type stuff, that's available, supplemental content. I think that's all we usually plug. Goodbye, YouTube. Twitch, let's find someone to raid.